In this video, we're going to be talking about the three different forms of a quadratic equation. So whenever we're looking at a quadratic equation, first of all, it means that we're going to see some sort of x squared or two x's showing up somewhere in the equation, okay? And there's three different forms you can write these in. The first form is called a standard form, and it looks like ax squared plus bx plus c. The second form is vertex form, and it looks like that formula right there. And then the last form is factored form, okay? So first we're just going to look at some examples of each of the different versions and different forms that we have, okay? So let me give you an example of an equation in standard form. So if I have 3x squared plus 5x minus 6, that is an equation in standard form. One way to think about this is that everything's already been multiplied, okay? We have everything written out just as a bunch of things being added and subtracted together. And it's important that when your equation's in standard form that you can identify A, B, and C, which are the coefficients or the numbers in front of your x squareds or your variables, okay? So in this case, your A is 3, your B is 5, and your C is a -6. Okay. One thing to be cautious of is that you do have to carry the negative down with the 6. So whenever you're subtracting, the A, B, or C value will be negative. Okay. Let's look at an example of vertex form. So if I have f of x equals x minus 3 squared plus 9, that is going to be in vertex form. Okay. It looks like a set of parentheses squared and then plus or minus a number at the end. And when you're in vertex form, it's important to recognize what A, H, and K are. Okay, A is the number that sits in front of your set of parentheses. So in this case, our A is 1. The H is whatever number you're subtracting from the inside or from the x. So in this case, our H is 3. And then our K is whatever number we're adding on to the end, which is 9. Okay. And then finally, let's look at something in factored form. So let's say we have f of x equals 11 times x plus 13 times x minus 2. So we recognize that's in factored form because I have two sets of parentheses. Neither of them are squared. And that kind of matches up with that factored form. Okay. So our a is the number in front. So if you recognize a is kind of consistent between all three forms. There's always an a. Our p is going to be -13 and our q is 2. So one thing to look at here that might be sort of confusing is that within the parentheses we're always subtracting. So when we find p and q, we're looking for kind of like the negative number that's going inside. So even though we have x plus 13, my p that I'm going to write down here is a -13 because it's like x minus a -13. Okay. So we're going to go through and look at a couple more examples of each of these so we can see what they look like. A couple things to be aware of. Just so you know, why would we even care about A, B, C, or H, or K, or P, or Q? Well, as we move forward in this unit, we're going to start graphing these quadratic equations, and these different numbers, the B, the C, the P, or the K, they tell you different things about the graph. So we want to be really fast at recognizing what those numbers are, because then when we get to graphing, it's going to speed up that process quite a bit for us. Okay, let's look at another equation in vertex form. We've already done quite a bit of practice with standard form because identifying A, B, and C is what we do when we're doing the quadratic formula. So we're going to spend a little bit less time on that today. So first of all, one thing that cues you in that you're in vertex form is that you have some set of parentheses squared. Okay, so the squared exponent is sitting outside of a parenthesis. And let's go ahead and identify our A, H, and K. So our A is the number in front, so it's 7. The H is the number that's being subtracted from x. So if you look back to our original form at the top, we have x minus h squared. So in this case, we have x plus 1 inside, which means our h is going to be -1. So it's kind of like the opposite sign of what's given. And then our k is whatever number is being added to the end. In this case, since we're subtracting from the end, it's it's going to be a negative 12. Okay, so that is my AH and K for that vertex form. Okay. Let's look through one more example of factored form. So this one's going to look a little bit different than the factored form that we just barely did. 5x times x plus 9. Okay. So I'm going to add in a set of parentheses that is going to help us look a little bit more like factored form. I'm going to put this x, whoops, that's kind of messy. I'm going to put the x that's right next to the 5 in its own little set of parentheses. And now that looks a little bit more like factored form. There's a number in front, and then there's two sets of parentheses that each have one x in them. So the a is going to be the 5 that sits in front of the equation. The p is whatever number I'm subtracting from my first x. So in this case, I'm not subtracting anything from my first x, so p is 0. And then my q is whatever I'm subtracting from the second x, which in this case is a negative 9. Okay. So if you are using the notes that we have posted, then you should be able to look at the next page of this and be able to get a list of 15 different equations and practice sorting them into each form. One thing to recognize is that sometimes an equation can fit into multiple forms. So you'll have to look at what some of those might look like too. In fact, let's even take a look at one of these equations that would fit in multiple forms. Okay. So I'm going to skip a line and just do it right here. We're going to do it as f of x equals x squared minus 12. So initially when I look at that, I think that it looks like it's in standard form, right? Everything's kind of multiplied out. There's no parentheses, so it seems to match up with standard form. So let's go ahead and determine what a, b, and c are. Your a is 1. That's the number in front of the x squared. Your b is 0 because we don't have any x terms. And then my c is negative 12 because that's the constant that I'm subtracting at the end. So f of x equals x squared minus 12 is in standard form. We can also consider it to be in vertex form. Okay. One way that might help you see that it's in vertex form is to add in these parentheses around, oh, my pen just stopped working. To add in these parentheses around the x. Okay. So we have x being squared, and then we're subtracting something at the end. Okay, let's go through and identify AH and K, and that might help you see even more how this one's in vertex form. So your A is the number in front, and in this case there is no number, so it's just going to be a 1. Your H is the number that you're subtracting from the X. And in this case we're not subtracting anything, so our H is 0. And the K is the number that we're adding on the end, so in this case it's going to be a negative 12. Okay. So this is just one example. This row that we just barely did right here is one example of when an equation would be in multiple forms. It's both in standard form and in vertex form simultaneously.